I think that everyone can agree that rocket engines are some of the most beautiful designs mankind has ever developed. I mean, just look at this thing. This thing is freaking amazing. Chemical rockets like the one in the previous clips are incredible machines, but they're only the tip of the iceberg when it comes to engine efficiency. And this is where nuclear engines start to look really good. In traditional chemical rockets, chemical reactions happen inside the engine's combustion chamber, which creates high-velocity particles that shoot off in one direction while making the spacecraft travel in the opposite direction. Nuclear engines, on the other hand, heats up hydrogen fuel to extraordinary temperatures and shoots it off the exhaust nozzle at tremendous velocity. First, the hydrogen travels into the nuclear engine's nozzles, cooling it down in the process. Secondly, the hydrogen fuel flows right back up into a series of pumps that turn it into a high-pressure fluid, directing it into the center of the nuclear engine, which is a nuclear reactor, and heating up the hydrogen fuel in the process. And lastly, the hydrogen fuel is superheated into thousands of degrees Kelvin and is shot right back out the engine. A measure of an engine's efficiency is known as the specific impulse. The higher the specific impulse, the better. This is because when the specific impulse is high, it takes less fuel to produce a given amount of thrust. In this example animation, the bottom engine has a higher specific impulse than the top one. Specific impulse is measured in seconds because it measures how long a spacecraft has its fuel left before it runs out. While the best chemical rockets have its fuel around 400 seconds, nuclear engines on the other hand can reach thousands of seconds. Nuclear engines have a high specific impulse because of the temperature, and hydrogen is the lightest element in the universe, therefore making it extremely easy to accelerate. Nuclear engines are advantageous in many ways, such as reducing the travel time to Mars by 25% or higher. And this is important because it reduces astronauts' exposure to radiation. Current interplanetary travel methods require planetary alignment to use the less fuel for travel. During the periods where the planets aren't aligned, chemical rockets are simply unable to deliver cargo to Mars, while nuclear engines, on the other hand, can do so regardless of planetary positions. So with all the advantages, it begs the question, are there any caveats to this technology? I mean, there's radioactive elements on board, what's the worst that could go wrong? You see, when a rocket launch goes wrong and results in an explosion, it will spread radioactive materials all over the environment for miles on end. And nobody knows how to solve that yet. And yeah, nuclear reactors can get really hot. On Earth, we have water to cool the reactors down, and we have air for convection, but in space there isn't air or water at all. There's a problem of overheating. But should that discourage us from using this new technology? No. Instead, we should take our resources to fund the development and research and safety of nuclear technology, because the benefits are undeniable. And maybe in the near future, most of our technology will be nuclear powered. And thanks for watching.